Hello students, in the last lecture we have discussed about combination of resistances. One is series combination and another is parallel combination. In series combination the result is R1 plus R2 plus R3 up to any number. And in parallel combination 1 by R1 plus 1 by R2 plus 1 by R3 up to any number. This is for parallel combination. In series combination, resistance is the sum of individual resistances, and in parallel combination, the reciprocal of net resistance is equals to the sum of reciprocal of individual resistances. So here we will see what is beneficial, means which combination is beneficial and which is not beneficial. Here the resistance in series R1 plus R2 plus R3 up to Rn. It means the resistance will be maximum. So in series combination the resistance is maximum, and in parallel resistance all are reciprocals, so here the resistance will be less. The resistance is minimum, we can say. So why do we combine the resistances in series? For making the resistance maximum. And why we combine all these resistances in parallel? For making the resistance minimum. In parallel combination resistance is minimum, and in series combination resistance is maximum. So whenever it is given that there are 4 resistances, 4 ohm, 6 ohm and 10 ohm. Find the minimum resistance and maximum resistance. It can be given in the question. So we have to find the minimum resistance and maximum resistance. Minimum resistance. For minimum resistance. For minimum resistance we have to find out the parallel combination. Means 1 by Rp will be 1 by 4 plus 1 by 6 plus 1 by 10. Here this will be 120, 30 plus 20 plus 12. It will be 62 by 120. So resistance will be Rp will be 120 by 62. Cut it, 31 by 60. It is the resistance in parallel combination. 1 by 4, 1 by 6, 1 by 10. LCM 120, 30 plus 20 and plus 12. 50, 62 by 120. The reciprocal of resistance will be Rp. It will be 120 by 62. It will be 60 by 31. You can find out the place values also. Find it in the point forms. Next, for maximum resistance. Maximum resistance is in series, so it will be 4 plus 6 plus 10. It will be 20 ohm. You can see here, this is the minimum resistance, this is the maximum resistance. So when we have to find the maximum resistance, just combine the resistances in series. When we have to find the minimum resistance, combine the resistances into parallel combination. Is it clear? Okay. Next advantage of parallel combination over the series combination. Advantage of parallel combination over series combination. In series combination, resistances are combined as, this is R1, R2, R3. And in parallel combination, resistances are combined as follows. You can see here, this is R1, R2, R3. Here I am showing the key. Yes, current will flow from positive to negative terminal, from here to here. This is the direction of current. Direction of current is from positive to negative. Check here, if the current flows from here, then same current will pass from R1, same current will pass from R2, same current will pass from R3. When one of the appliances is damaged, if any appliance of the appliances is damaged, then the circuit will be broken, we can say. If it is damaged, then circuit will be broken. Means it will be open circuit, and the next components will not work perfectly. Means if one of the component starts working, then the next components will start working, because the combination is series combination. The current flows from one to second to third. Is it clear? Means if one is damaged, all will not work. This is R1. When R1 is damaged, R2, R3 will also not work. When R2 is damaged, then R1 will work or not. We can see, means next components will not work, because the circuit will be open, this will also not work. Means one component is damaged, all will stop working, because the circuit will be open circuit when one of the component is damaged. This is the main drawback of series combination. Drawback of series combination, or say advantage of parallel combination. In series, if one component stops working, all components will also stop. If one component stops working, all components will also stop. And next is what? If we give any amount of current, the current will be same for this, same for this, and same for this. Means the current required for different components may be different. At our homes, for electric iron, for fan, for LED, most of them have different needs of different value of current. But in series combination, the same current goes in resistance 1, resistance 2 and resistance 3. So it is also the drawback of series combination. In series combination, if in series combination same current will pass through all components, whereas the requirement may be different. The current from all the components will be same in series combination, whereas the requirement may be different for different components. This is also the drawback of series combination. And in parallel combination, if current is going from this point, then it will go from here, it will go from here, it will go from here. We can see. And the values of current will be different for each component because current is divided into some parts. We can see here. If one of the components stops working, then other will not stop working because the circuit is complete for the other components. You can see here. The circuit is from positive to negative is complete. The circuit from positive to negative is complete. Is it clear? And next point we have seen earlier. The resistance is maximum in series combination while the resistance is minimum in parallel combination. We can see here. So these were the advantages of parallel combination and disadvantage of series combination. Next is heating effect of electrical components. We can see at our homes when electrical components are working, then they are getting heated. This is the law of heating effect, due to heating effect. Means when current is passed through a conductor, some of the energy is converted into heat energy. And it depends on the amount of current, say intensity of current. Maximum is the current, maximum will be heat. Maximum the time the component is working, maximum will be heat. Maximum is the resistance, maximum will be heat. So heating effect of electric current. We are discussing about heating effect of electric current. And for a purely resistive, means if a component has high resistance, most of the electric energy is converted into heat energy. So heating effect of electric current, we will discuss about the conversion of electrical energy into heat energy. For a purely resistive component, for a purely resistive electrical component or say device, I am writing here, most of the electric energy is converted into heat energy. We can see in electric iron, in electric heater, means room heaters, geysers, toasters, and in bulb too. Heating effect of electric current means four are purely resistive component. If the resistance of this component is very high, then the electrical energy will be converted into heat energy. Most of the electrical energy is converted into heat energy and the device will be hot. If it is an electric iron, then we give it electric current and it will be hot. This is the heating effect of electric current. For a toaster, for microwave oven, and for electric bulb, for geysers, the same phenomena works, means heating effect of electric current is used there. Joules law of heating effect. One of the physicists named as Joule described the heating effect. That heating effect means the heat of the components depend on some factors. These factors are current, resistance, and the time. If maximum is the current, then the heat will be more. If time is more, then also the heat will be more. We can see at our homes when fan is working for long time, then it will get heated. Same for all components. If an electronic component work for long time, then it will be heated. It is clear. So Joule's law of heating effect, it states that the heat due to electric current is directly proportional to the square of current flowing, to the square of current flowing through the conductor. It states that the heat due to electric current is directly proportional. Heat due to electric current is directly proportional to the square of electric current. The first thing he told. Next thing. Heat is directly proportional to the resistance of the conductor or the device. Means heat is directly proportional to the resistance. And the third factor is time. Longer the time, larger will be heat, more will be the heat. And third is heat is directly proportional to the time of working of the conductor or time of working of the component. Means more the time the current is flowing, more will be the heat produced. More is the current, more will be heat. More is the resistance, more will be heat. And more is the time, more will be heat. From these three relations, we can see that heat is directly proportional square of current, resistance and time. This is Joule's heating effect. Is it clear? Next, some components are desirable, means the heating effect is desirable at our homes for some components and non-desirable for other components. Like in refrigerator, AC, fans, it is non-desirable. We do not want that they should be heated. Means if fan is working, it gets heated. If AC is working, it gets heated. If refrigerator is working, it gets heated. It is non-desirable. We don't want to get them heated. But in some appliances, we want them to be heated, like electric iron, like room heater, like microwave oven and toaster. So it is desirable in some electrical devices like heater, electric iron and geyser, microwave oven and in iron, geyser, heater, microwave oven and toaster, etc. And it is non-desirable. It is desirable in components like fan, AC, refrigerator, etc. Here are too many components in which the heating effect is non-desirable. Is it clear? Today we have learnt about the series combination. In the series combination, resistance is maximum and in parallel combination, resistance is minimum. Next, advantage of parallel combination. Parallel combination is more convenient because in parallel combination, if one device stops working, all the device will be working continuously. And the resistance in parallel combination is minimum. And the value of current will be different for different components in parallel combination. While in series combination, if one device stops working, all the devices will stop working. Means circuit will be broken due to damage of one device. Next, the resistance is maximum in a series combination. Next point is all the device will not work if one of them is stops working. Next, heating effect. When we pass the current from any conductor. Some of the electrical energy gets converted into heat energy, and 4 are purely resistive. If the resistance is high, then the device will be called as purely resistive device. 4 are purely resistive device. Most of the electrical energy is converted into heat energy. Most of the electrical energy is converted into heat energy. In which device? In purely resistive device. And other devices, all the devices have some of the value of resistance, so they will also have heating effect. Joule's law of heating. Joule says that the heating effect means the heat is directly proportional to the square of current, directly proportional to the resistance of conductor, and directly proportional to the time the current is flowing. From all these three, heat is directly proportional square of current, directly proportional to the resistance, directly proportional to the time. It means electrical energy is converted into heat energy. Heat will be more when the current will be more. Heat will be more when the resistance will be more. Heat will be more when the operating time is more. Is it clear? Next, this heating effect is usable and non-usable. Means desirable and non-desirable. In desirable form, we use it for electric heater, iron, geyser, microwave oven, toaster, etc. But it is non-desirable in other components like fan, AC, refrigerator, etc. We don't want to be heated these components. So it is both desirable and non-desirable, means here are some of the benefits and some of the harms of heating effect. And it is also desirable in electric fuse also, you can say the most important electric fuse. In the next lecture we will discuss about electrical fuse. It is a safety device.